In this video, we'll look at how to work with SQLite in C#. SQLite is a very popular serverless database that you can distribute with your application without the need to install any special server software. To keep things simple, this video will use ado.net to access our SQLite database. We'll start by installing Microsoft's NuGet package to work with SQLite, then go through the process of setting up a connection string and connecting to the database. We'll create a table in the database and its associated model or entity class. Then we'll demonstrate the 4 CRUD functions to create, read, update, and delete from an SQLite database. First, we need the SQLite NuGet package. Right-click the project and select Manage NuGet Packages. From the Browse tab, search for microsoft.data.sqlite. Do not install the core version because this does not include the native SQLite library. Install the microsoft.data.sqlite package. We'll add a separate class where we can do all our SQLite stuff. We'll call the class Data Access. Next, we need a configuration file where we can specify a proper connection string. Right-click the project and select Add New Item. From the General section, select Application Configuration File and keep the default app.config name. In the configuration file, add a connection strings section. Then, add a connection string. We'll give it the name sample and set our data source file to be sample.db. Back in our data access class, we define a class-level variable to hold the connection string. The constructor method will accept a database name as argument. This will be the name of the connection string in our config file. Use the configuration manager to retrieve the connection string. You may need to do a control period on the configuration manager and select Install Latest. Once installed, use the connection strings method with the database name as index. In our main method, we can now instantiate a data access object with the name of our sample database. Let's write a method in the data access class to test the connection to our new database. We define a SQLite connection object using our connection string. Then use the con object to open and close a connection. Note that SQLite will create a database file if it doesn't exist. If all goes well, we display a confirmation message. Otherwise, display the exception message in the catch block. In our main method, we invoke the test connection method. Our connection is okay. The sample.db file didn't exist when we started, but when we tried to connect to it, the SQLite connection object created it for us. Before we start creating tables and adding data, let's create a class to represent a model or entity in our database. The person model will represent a row in our people table, which we'll create in a moment. It will consist of 3 columns: the ID, first name, and last name. In the data access class, we create a method called createTable. Since we're using ADO.NET, we'll have to pass a SQL statement to it. Here, the SQL statement says, create a table if it doesn't exist, and call it people. It must consist of an integer primary key called ID, and the database must automatically assign a value to it when the row is inserted. It should also have first name and last name text columns. Here we say that these text values cannot be null, but that's more a preference than a convention. In our try-catch block, we use using statements to ensure the database is closed and all objects are disposed of once we're done. We first create our connection object and open the connection. Then, we create a SQLite command object and pass the SQL command and connection object as arguments. With that set up, we can call the command's execute non-query method. If successful, it displays a confirmation, otherwise it displays the exception message. Back in the main method, we invoke the data access object's createTable. The people table is okay. It either created it or it already existed. On to the CRUD methods. Our first method is to create or insert a person record into the people table. Here we created an insertPerson method that will accept a person object. Then we set up the SQL command to insert a row into the people table. Notice that we only need to give it the first name and last name, since ID will be auto-generated by the database. Also, we set the values as parameters so we don't directly pass values into our SQL statement. In the try-catch block, we define a variable to hold the number of records affected. This is just for demonstration, and you don't need to do this if you're not interested in this value. Next, we create our connection and command objects again and add the parameter values we need into the command object's parameters list. Make sure the parameter names correspond to the parameters in the SQL command. With that all set up, we call the command's execute non-query method, which can return the number of records affected. Then we simply display the result or any exception if the code failed. In our main method, we create 2 person objects to insert into the database. Then simply call our data access object's insertPerson method with our person objects. The output shows the result of the 2 method calls. Next on the CRUD list is reading. We create a getAllPeople method in the data access class to return a list of person objects from our database. The SQL query is a simple select all from the people table. After creating our connection and command objects, we need a reader object to read from the database. The executeReader method will use the select statement to create a reader object with a set of data. In line 95, for demonstration purposes, we check if the reader has any rows to read before continuing. This is not really necessary since the while statement that follows will break out of the loop anyways if there's no rows to read. If there are rows, the while loop will read each row, creating a new person object, and convert the values from the row to the proper types in the person object. It then adds the new person object to the result list. When all is done and there are no exceptions, the method will return the result list. In our main method, we call the getAllPeople method from our data access object to get the list of person objects. Then we loop through the list and display each person. Here we see the auto-incremented ID values that were assigned to the records when we inserted them. We'll add another read method, this time to get a person record by its ID value. We set up a temporary person object to hold the result of the retrieved data. Note, we set this as null with the intention that if there's no person record found, the method will return a null value. The SQL statement selects a person based on the value of the ID parameter. After setting up the connection and command objects, we add the ID value to the command's parameter list. After creating the reader, we have to check if the reader's dataset contains any rows. If it does, we read the first row and create the person object. Finally, the method returns the person object, which could be null if no records were found. In the main method, we define a variable to hold the ID number since we'll use this later. Then, we call our data access objects getPersonById with the value of the ID variable. It then checks if the returned person object is not null and display the result. Else, there was no person record found for that ID. The output shows that person with ID 2 was found, and it displays the person's details. Let's test our fail code by changing the ID's value to 5. Now the output shows it couldn't find a person with ID 5. For updating, we created an updatePerson method that takes a person object as argument. The person object should contain the ID to be updated and the changed values of that person. The SQL statement changes the values for a person with the specified ID. After creating the connection and command objects, we add the new values to the command's parameter list. Then, simply call its executeNonQuery method. In our main method, we declare a person object with the ID of the person we wish to update and the updated values. We call our data access object's updatePerson method with the new person values. To see if this worked, we go read the person object back from the database and display its details. Here we see one record was updated and person with ID 2 displays the updated values. Our final step in the CRUD list is the delete method. We create a deletePerson method that takes the ID of the person we wish to delete. The SQL statement deletes a person from the people table with the specified ID. After creating our connection and command objects, we add the ID to the command's parameter list and call its executeNonQuery method. In our main function, we declare a variable to hold the ID we want to delete. Then call the data access object's deletePerson method with the ID's value. To check if this worked, we try to read the person back from the database, and if the result is null, the record was deleted. In the output, we see that one record was deleted, and it can no longer find it in the database. Thank you for watching our video. For more tutorials on C#, hit subscribe and click the reminder. Give us a like so the video can be visible to more people.